Well, welcome back. It's now time to have a look at some summary statistics. So it's all stuff you've been doing since year 7, but it's building and building and building. So we're going to try and sneak through a fair bit in this video, but feel free to skip forward to each section that you want to do individually, which is what most maths courses seem to do. So you can see here, summary statistics. And we're going to be looking at measures of centre and measures of spread. Now, they refer to a couple of different things. Measures of centre first, we've got a few options. We have the mean, which of course is, if you remember back, is just the average. We have the median, which is the middle value. And we have the mode, which is simply the most common value in your data. We're going to go through these individually in a moment. This is just reminding you what's what. So mean, average, median, middle, mode, most common. Measures of spread. We are talking about the range, which is simply the largest minus the smallest value. Okay, you see that just below me here. The other one, which you may or may not have seen so far, is the interquartile range, IQR. Okay, interquartile range. Now that is the difference between, we're basically splitting the data up into quarters, and it's the difference between the third quarter and the first quarter values. Again, we'll deal with that shortly. And finally, rounding it all up, now this is starting to head into VCE Further Maths area, is we're going to look at the 5-figure summary. Okay, like I said, feel free to skip forward to whichever part you're after, but that's what we're going to be looking at today. The first bit we're going to look at today is the mean, which of course, if you remember, is the average of the data. You remember how to do this? It was simply add up all of the data. Now, I'm going to introduce you to, we add up all the data and then divide by the number of bits there are, but I'm going to introduce you to a bit of how we write it properly. So we can write it as the mean equals, now this symbol here means the sum of, it's a Greek letter, it means the sum of all the x's, and x represents a score. So this just simply means, sorry about that, the mean is simply the sum of all the data, which is what we've got here. Add up all the data, the sum of all the data. And then we divide by the number of bits of data, which is just simply n. So the sum of all the data divided by n. Got that? Make sense? All right, let's look at an example. Here's some data. I think there are 19, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19 bits of data there. So all we need to do is add up all the data. Great. I'm going to give you a tip though. This is the biggest mistake we see when people go to add up all the data in their calculator. They do all that, great, then just press divide. Divide by, now we had 19 bits of data, divide by 19. That will give you the wrong answer because, think back to BODMAS. You got all these additions here, or BIDMAS, all these additions, and then you hit a divide. What does the calculator do first? It does the divide first. So it does the 13 divided by 19 first. That will give you the wrong answer. So you have a couple of ways of doing it. You can add up all these bits of data, then press equals, then press 19, or you can use brackets, as you can see here. I've just used brackets, and then I'm going to do divide by 19. All right. Same as I just like it because it's got brackets up here, put brackets down there. Makes sense, doesn't it? Equals 209 over 19, skipping ahead a bit, which equals 11. So the mean equals 11, and it's always a good idea to write a little statement saying the mean or average score was 11. Pretty easy. Now we have a couple of other ways that the data can be shown. This works nice and easily if you've just got data all spread out like this, just listed. What happens though if you've got your data in a frequency table? we've got the scores, we've got threes, and the frequency table means I've got 2 threes. I've got 8 fours, and I've got 6 fives. We're going to use a very similar formula, except this time it's the sum of x times the frequency. So if it's in a table like this, and then divided by the n. Okay. If it's in a table like this, we want to add in an extra column. So, and that is going to be our x times f, just down here. So we'll put our x times f there, and we've got our score x, we've got our f. So 3 times 2 is, of course, 6. 4 times 8 is 32, and 5 times 6 is 30. Okay, now for this one, we just need extra bit down the bottom here. We need to know the total number of bits we've got. So we have 2 threes, 8 fours, 6 fives. There are 16 bits of data. Add up all those. And we're over here in the equation, you can see we've got the sum of x times f, so we have to add all of them up. So we'll just put the total in there. Now we've got our 2 numbers, which we just sub straight into the equation, which is 68 over 16. 68 divided by 16, the mean is 6.18, which of course we then write the mean or average score was 6.18. Relate it back to the question. If the question's about the length of somebody's finger, you'd say the average finger length was 6.18 centimeters, something like that. Now we have one other way the data can be represented. Now that is if it is grouped data. So that's where you've got a range of data. So grouped data could be either discrete or it could be continuous like this. If it was discrete, it'd say 30 to 39. If it's continuous, it'd say 30 to less than 40. Very, very similar again. The equation, mean, is the sum of the midpoint of x times the frequency. So we can't do 2 times 30 to 40. The best we can do, we're hedging our bets a little bit here. The best we can do in this situation is use the middle of that range. So we'll add a column and we'll make this column the midpoint of x. So halfway between 30 and 40 is 35. Halfway is 45 and halfway is 55. Now we're doing midpoint times the frequency. So we need another column, same as we did up here, score times frequency. Now we'll do midpoint times frequency. So we'll add another row of boxes over here, give it a title, midpoint of x times f. Simply 2 times 35 is 70, straightforward. 8 times 45, 360, I just knew that. And 6 times 55 is 330. Now we'll do our totals on the bottom. Now, which totals do we need? Let's have a think. So the sum of midpoint times of mid x times f, put my teeth back in, mid x times f. So we'll need that one there, and we need the number of bits. So that will be down here. So let's put one down here, 16. And here's the last one we need. We've got all we want. Bang it in the formula. 760 is the sum up the top, divided by the 16. 760 divided by 16 is 47.5. Okay, got that? You see how all the formulas are related. Starts off with the basic. If you've got your data, just add them all up, divided by how many you got. Over here, if it's in a table, you just put an extra column. The sum of score times the frequency, divided by how many you got. And if it's groups data, use the midpoint times the frequency. All related. Right, go get some practice on mean. Next one we're going to look at is median. Now remember, median means the middle piece of data, as it says up here, the middle score. Okay, so what we have to do first, this was the painful one, is get all of your data in order. Now I'm going to skip through the steps here and then we'll do an example. If the middle bit of data is a number, then that's the median. So you list all your data in order and work your way through it, find the middle. If it lands on a number, that number is the median. If, however, the middle bit of data is between two numbers, so let's say it's between 16 and 18, halfway between is the median. So halfway between 16 and 18, of course, is 17. So let's have a look at one here. We've got the same numbers as we used in the mean example. We've got 19 numbers. Let's have a look. First step. They're not in order, are they? 11, 15, 9. No. So the first thing we have to do is rewrite them in order. Now, this is really, really, really important that you do this carefully. So 5, you see how I've crossed the 5 off. Make sure I'm not going to miss anything. There's another 5 over there. Next number, let's have a look. Next biggest to 5 is the 7. No, there's a 6, is it? There's a 6. There's a 7. And there's a 7. Really mucking this up, aren't I? They're all there. What comes after the 7? There's a 9. There's a 9. There's an 8 even. I'm going to start this video again. Okay, let's go backwards. Now remember, this is the middle value in your set of scores. Okay, so we're just going to go through a few steps here and then we're going to do an example. So the main bit we have to remember is make sure your data is in order. Okay, has to be in order, smallest to largest, largest to smallest. That doesn't matter, so long as it's in order. Most of the time, we have it smallest to largest. Now, 2 points to remember here. If the middle bit of data is a number, then that is the median. So if you work your way through your list of data and it comes up, for example, you're crossing them off from each end, you get to a number, that's your median. If, however, the middle bit of data, so you cross, oh, hang on, I can't cross the last one off, then it's halfway between. For example, if you get 16 and 18, there's your two middle bits of data, then halfway between, so 17, halfway between is your median. Let's have a look at an example. Here's the numbers we used from the last page and mean. Same numbers, 11, 15, 9, they're definitely not in order. So please take a little bit of extra time and get these numbers in order. Now, you see what I've done here? I've put a 5. That is the smallest number there. Have a look through. There's another 5. See how I'm crossing it off? Really important you don't miss numbers too. Now, what comes after 5 is there's 9s, 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 8s, 12, 7, there's a 6. So we'll put a 6 and cross it off. I did see a 7 and there's a 7 up there. So we'll put a 7 and there's the other 7. What do we go? Oh, there's an 8 over here. And there's a 9 and there's another 9. And I'm not going to bore you with this crossing them off. So I'm skipping ahead. There we go. All the numbers in order. Now, what you do when you're first learning about median in year 7 is you cross one off here and then you cross one off here and work your way back to the middle. Okay, that's great. It's slow, covers up all your numbers again. So if you need to do something else, you can't see the numbers. You could suppose you could tick them, but this only really works with a small amount of data. What happens if you've got 200 bits of data or 500 or more? It's not really going to work. So we've got a little equation which will help us out here. Use n plus 1 over 2. Now, n was a number of bits of data. plus 1 over 2, that will find the position of the middle bit of data. So let's see how this works. Now we had 19 bits of data, still needs to be in order. 19 bits of data, so we'll write out n plus 1 over 2 down here. N plus 1 over 2, n is 19, so it becomes 19 bits of data. I'll just write it just in case. 19 plus 1 over 2, which is 20 over 2, which is, now this is the important bit, 10th bit of data. It's not 10, it's the 10th bit of data. So then all we need to go along and do is go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is our 10th bit of data. That is the median. Bit simpler. And of course, you finish it off with a statement. The median or the middle score was 11. Just going on this again. The n plus 1 over 2 gives you the middle position. Okay. So down here, it's a really good idea to write the 10th bit of data. Don't write 10. Often you'll see people write 10 and say the median is 10. That's not right. It's the 10th bit of data where the median is. So you go through and count to where the median is and give that answer. All right. Now we've got another way we can represent data. I'll put it over here. This is a stem and leaf plot. Different set of data again, just some more data. Is it? Oh, it's almost the same. I think I've added in a little extra number. I've added a 22 in there. I have. So it's 0, 5. And, oh, no, I can't read it. I haven't got the key. There's the key. Okay. 0, 5 is 5, 5, 6, 7, 7. It is the same data all the way up to 21. And I think I've snuck in a 22 in there. 2 and 2 makes 22. So we use the same thing. There are 20 bits of data. Make a note. Use the n plus 1 over 2. So 20 plus 1 over 2 is 21 over 2, which is 21 over 2 is 10 and a half. 10 and a half bit of data. So count through it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's in between those two, isn't it? Remember, if it's in between the numbers. So halfway between there is 11 and a half. Between 11 and 12 is 11 and a half. Okay, we got a bit more on median. Hold your horses. You got that, the n plus 1 over 2. Let's have a look at if your data is in a frequency table. All right, here's our frequency table. Scores are 3, 4, 5 again. We've got 3, 8, and 14. This you have to be a little bit more careful with. Now, I'm going to introduce you to a term called cumulative frequency, which is just a running total of all the frequencies. Okay. So what we're doing, we're adding an extra column, just like this. Here it is. And we're going to make this a cumulative frequency or CF column, not cystic fibrosis, cumulative frequency. Okay, this is a running total of the frequencies. So far we've got, in this box, we've got a frequency of 3. So we can put a 3 here. Then running total, we've got 3, we've got 8 more here. So 3 plus 8 is 11. Running total, 11 plus 14, which is, of course, 25. Got that? Straightforward. Start with there, 3 plus that, 11 plus that is that. Now, we're still going to use our n plus 1 formula, n plus 1 over 2. How many bits of data do we have? We have 25. So it's 25 plus 1 over 2, which is 26 over 2. Which is our 13th bit of data. Now, this is a bit we have to look for. Our 13th bit of data is in here, but that says 25 and that says 14. Let's have a look. We've got 3 to there. We've got 11 to there. So all up in here, we've got 11 bits of data. Think about it. 12, 13 comes straight after 11, doesn't it? So that's going to be in this column. Now the median is talking about the score. This tells you where it is. Our 13th bit of data is here. So our median is going to be 5. So it's all about the score with median. Our 13th bit of data is in this row. There's our data in this row. Now, we can check that. We can prove that. This frequency table says we've got 3 3s. So let's write 3 3s. We've now got 8 4s. So we can do 8 4s down here. And we've got 14 5s. There's our 14 5s. Right, so we're looking for our 13th bit of data. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There it is. There's our median. All right. Now, sorry, just moving something up over here. What if we've got grouped data? There we go. Here's some grouped data. 30 to 40, 40 to 50, 50 to 60. Again, we need an extra table. Can you think of what's going to go in there in group data? Correct. We need the midpoint. The midpoint of the score, again, is 35, 45, and 55. Cumulative frequency. It's a frequency table. So let's do our extra row and add in our cumulative frequency title. Cumulative frequency. Remember, it's frequency here. So we start with our 2. 2 plus the 8 is 10. 10 plus the 6 is 16. N plus 1 over 2. We've got 16 bits of data. So 16 plus 1 over 2 is 17 over 2, which is our 17 over 2 is 8.5. 8.5 bit of data. It's hard to say. Let's look at our table again. 2, 3, 4, 5, 6, 7, 8. It hits below 10, doesn't it? So 8.5 bit of data is going to be here. It's in this grouping range, but again, it's group data. We don't know exactly what the data is. So we hedge our bets again and we use the midpoint of that group, which is 45. Got that? N plus 1 over 2. Great little formula, especially if you've got 200 bits of data. 200 plus 1 is 201. So you're looking for the 100.5 bit of data. Then you just count to 100.5. If you're lucky, your data's set out in a grid. And you just go 10, 20, 30, 40, and so on. You get it. So frequency table, add your cumulative frequencies. If it's grouped, add your midpoint and then your cumulative frequencies. All right. Go have some practice on that one. All right, this is the easiest one to get to for statistics. Mode, the most common piece of data. All right, let's get some data up. Here's our data again, same data. Let's look for the most common bit of data. We've got 11 there, another 11 there. We've got 15, no more 15s, 9, there's 2 9s, 14, 14, 16, 7, 7, 13, 13. Oh, hang on. 3 13s and 8. Let's have a look. We've got a 13 there. We've got a 13 there and we've got a 13 there. We've got 3 13s. So that means our mode is 13. Done. So the mode, or most common score, was 13. Straightforward, nice and easy. Just finding which is your highest frequency data. I've just added another number in here. Same data, but I've put another 9 down there. So we've still got our 13s, the 3 13s, but now we've got 1, 2, 3 9s. So 1, 2, 3 9s. That's fine. That means our mode, we've got 2 modes, 13 and 9, or 9 and 13 if you must. This is called bimodal. Bi meaning 2, it's got 2 modes. Great. Data's in, just laid out as numbers. That's fine. Just look through it, find the highest frequency number, the most common one. If it's in a frequency table though, 3, 4, 5, and here's our frequencies. This part's easy. We're looking for the highest frequency, aren't we? There it is, 14, which means our mode in this case is not 14. That's just the bit you got to be careful of. The mode is not 14. That's the highest frequency. That means we've got 14 lots of 5. Straightforward, that part, isn't it? Okay. Now it's time to look for some. We're finished with the measures of center, and now we can start looking at the measures of spread. So this starts with the range. Again, the easiest one, it is simply the largest minus the smallest score. So whatever your scores are, find the biggest one, find the smallest one, and go minus between them. Here's our data. Our biggest score here looks like 21. Our smallest score is 5. There it is. Okay, so we simply do the range equals 21 minus 5, which is, of course, 16. Put it in a sentence. The largest score was 21 and the smallest score was 5, giving a range of 16. Now, frequency table, same thing. Let's have a look. What's our largest score? Our largest score in this case is there, is 5. What's our smallest score? It is 3. So in this case, our range is 5 minus 3, which is 2. Really straightforward. For range, don't look at the frequencies, look at the scores. If it's as grouped data, there we go, grouped again, 30 to 40, 40 to 50. Now, this one, we don't use the midpoints. I know for the measures of center, we've used the midpoints. This, we don't know the actual scores. So the best we can say, our largest is 60, potentially 60. Our smallest is potentially 30. So our range is 60 minus 30. Now, when we use them, I'm going to talk about the range and the interquartile range a little bit later on when we combine them. But we need to be careful when we use the range. Certainly do it if the question asks you to find the range. But there's going to be a word of warning a little bit later on. Okay, next bit. Nearly there, interquartile range now. Now this is a little more complicated. Rather than writing interquartile range, yes, you can just write IQR. Now, quartile means quarters. So this is simply the difference, because it's a range, between the third quartile and the first quartile score. So what we're finding is where the middle 50% of the scores lie. So the bulk of your scores. Now, quartile means quarter. So essentially what we're doing is we need to break up the data into 4 equal lots, or quarters, or quartiles, if you like. It's a pretty straightforward process when you think about it. Here's some data. Data should look familiar. It's the same data we've been using all the way through. So we need to break it up into 4 groups. So a good place to start is by finding the middle bit of data, which is, of course, the median. That is the halfway point. So how do we find the median? It was n plus 1 over 2. So we've got 19 bits of data. 19 plus 1 over 2. We did this one already. 20 over 2, which is our 10th bit of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. There's 11 is our middle bit of data. Now, question for you. That's given our middle, but we want the quarter value. That's a halfway. What's half of a half? All right, it's a quarter. So the next bit we've got to find is the lower quartile, or the first quartile, or Q1 it's sometimes called. Half of a half gives us our quarter. So it's going to be somewhere in there, isn't it? Just looking at the numbers, half of a half. Hang on, we found the halfway using this, didn't we? But that was of all the data. So if we do this, how many bits of data we got there? We find the halfway of those bits of data. That'll give us a quarter, won't it? Great. 1, 2, 3, 4, 5, 6, 7, 8, 9 bits of data. So we'll use our n+1/2, which is 9 bits of data. So it's 10/2, which is our 5th bit of data. 1, 2, 3, 4, 5. There's our first quartile, our quarter value. Now, the good news is, the next bit we need to find is the third quarter, the upper quartile, or Q3. That's going to be up here. Now, if we had 9 bits of data on this side, how many bits of data do you think we're going to have on this side? 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 bits of data again. So we can just use that information again, can't we? So it's still going to be the 5th bit of data on this side. 1, 2, 3, 4, 5. There it is. There's our third quartile. Now here's the actual equation for interquartile range. It is IQR is Q3 minus Q1. So what was our Q3? It was 14 minus 7, which is, of course, just 7. So interquartile range is 7. Now, if you want to put that in a sentence, you could say the interquartile range is 7. You could also say the middle half of the scores were between 7 and 14. Okay, things like that. That means in here, 50% of your data is between the score of 7 and 14. Now, we use interquartile range. After range, I gave you a little word of warning. We use interquartile range. We can use it anytime, certainly when the question asks, but this in some ways is a more accurate representation of our data, and we're starting to step on VCE here. It allows for skewed data. It shows where the bulk is. So if we had a value up here of 60, data that's a long way away from here, if we just use the range and say 60 minus 5 is 55, which is huge. But when you've got all the data down here and one outlier up here, it's called an outlier, you might have heard of it before. This 60 up here doesn't really represent the data, does it? It shows up in the range. But if you look at the interquartile range, these numbers will shift a little bit, but not much. It basically discounts where that 60, that outlier, and will give you a more accurate representation saying, well, 50% of my scores were between 7 and 14, which is more accurate, okay? So, short version is, if your data is skewed or there is an outlier, a number that's way outside the rest of the data, that's where you use the interquartile range. Find the median, find the first quartile using the same formula, but just with the numbers in the bottom, and reuse that formula to find the third quartile, then just go Q3 minus Q1, and there's your interquartile range. So let's wrap it all up with our 5-figure summary. Now we use this to describe the spread of the data. Now, we need 5 things, 5-figure summary. We need a minimum score. We need the first quartile score. We need the median score. We use the third quartile score, and I think you can guess what's coming next. It's going to be the maximum score. You can see the 5 things. So here's some data. Again, looks very familiar. We've sort of done this, but we're going to go through it and combine it all into one thing. Easiest to find here, data's in order. What's the minimum score? 5. There it is. What's the next easiest? Is the maximum score. Don't have to do any calculations. There it is, 21. Next thing, now, I'm not going to do the calculations, the median. The median was how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. 19 plus 1 over 2 is 20 over 2, which is our 10th bit of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our median. So our median is 11. Great. 10th bit of data. I've got 9 on this side. So 9 plus 1 over 2 is 10 over 2, which is 5. 1, 2, 3, 4, 5. 5th bit of data. First quartile is 7. Add it in. You can see how quickly this goes, can't you? Second side is a 5th bit of data again. 1, 2, 3, 4, 5 is 14. So our Q3 is 14. All right, so here's our 5-figure summary. Now, what does it all mean? It allows you to say where, what's happening with your data is a good way of put it. So let's have a look at some comments you can make. The lower quarter of the scores were between. Now, this is quartiles, remember? So there's a quarter, there's a quarter, there's a quarter, there's a quarter in here. You know, 4 gaps. So the lower quartile, so between the minimum and the first quartile, that's there, were between 5 and 7. You can say that. Next bit, half of the scores were above. Now here's the important word, half of the scores were above. So we've got to look at our halfway score, which is median and above that value. So that's where we want it. So half of the scores were above 11. The middle half of the scores, here we go, the middle half of the scores were between. Where's the middle half of the scores? So that's a quarter, that's a quarter, that's a quarter, that's a quarter. So the middle half is going to be in here, isn't it? 7 and 14. There we go, 7 and 14. Next one. Straightforward. I'll give you an easy one. The highest score was, oh, that's easy, that's 21. And the lowest score, oh, that's easy, 5. What's that called again? That's called range. The middle half of the scores, what's that called? Oh, that's in quartile range, isn't it? Okay, so you see how it all links in together. Okay. That's just a brief, well, it's not that brief actually, it's pretty long. Pretty long. Well, here, we'll just throw another one. Hang on. 3/4 of the scores were above. Just make sure 3/4 were above. Hang on. So that means that's quarter, quarter, quarter. So that's going to be in there. 3/4 were above 7. Done. It is pretty long to do all that. And to do it by hand, it takes a long time. This is just the beginning, unfortunately. It all leads on to a whole stats goes on for a long way, and it's used in a lot of places. Calculation of outliers, for example, is what we're going to look at in a little while. Sketching graphs, such as box plots, dot plots, and histograms. You're going to be comparing data distributions. You're going to be making predictions. You're going to be looking at bivariate data. That means 2 variables. You've only been doing univariate. More sketching and scatter plots, which is again dealing with bivariate data. More predicting with regression lines. Oh, and so on. And this is just up to year 12, let alone in university. But don't panic. Do not panic. In VCE, you get to purchase one of these bad boys or bad girls, whatever you want to call your calculator. It's a CAS calculator, or there's an option for a ClassPad. There's a Casio version. These will do it all for you. You enter your data, press a few buttons, and it calculates them all for you. But that, my friends, is in VCE. We are walking before we run. Understand what you're doing and where you're applying it, and then you get to use this. So for now, I'm going to love you and leave you with all the fun of calculating the stats.